In this video, we'll learn about conditional statements. What is a conditional? It's a statement that follows the form if-then. It can be expressed symbolically as P arrow Q. And this little arrow means implies. So what I just circled is read as P implies Q. The statement is true unless a true hypothesis leads to a false conclusion. So here's an example of a conditional statement. If it rains, then the sidewalk will be wet. Like we said, a conditional statement has two parts. The first part, the hypothesis, is the if part, and the second part, the conclusion, is the then part. So in this example, if it's raining outside, that's the hypothesis. Then I'm not happy would be considered the conclusion. You can prove a conditional statement is false by finding just one counterexample. This means keep the hypothesis the same, but find something that could cause another conclusion. So, if we're talking about the conditional statement, if it's raining outside, then I'm not happy, the counterexample would be, there's a hurricane and the Giants won the Super Bowl. Because it fits the hypothesis, it's raining outside, but it leads to another conclusion, that I'm happy. And if the Giants win the Super Bowl, I'll be very happy. Let's practice finding counterexamples. The first conditional statement reads, if a number is divisible by 2, then it is divisible by 4. This statement is false because I could find a counterexample. The first number that comes to mind that's divisible by 2 is 2. But 2 is not divisible by 4. So since it fits the hypothesis but leads to a different conclusion, this would be a counterexample. So therefore, this first conditional statement would be false. In the second conditional statement, if a number is divisible by 4, then it's divisible by 2. If I think of any example of a number divisible by 4, say 4, 8, 12, they're all also divisible by 2. So these would not be examples of counterexamples, which means that this conditional statement is most likely true. And in order to know that for sure, you would have to prove it. But we're not going to do that right now. Let's move on to converse statements. When you think of converse, think reverse. So the converse of a conditional statement switches the hypothesis and the conclusion. So, if we had a conditional statement, if it rained, then the sidewalk will be wet, the converse to that statement would be, if the sidewalk is wet, then it rained. See how we switched the hypothesis and the conclusion there? So when you flip them, when you reverse them, that's a converse. The next type of conditional statement is a biconditional statement. So when you see that prefix bi right here, think 2, because you're writing the hypothesis and the conclusion two different ways. So a biconditional statement includes both a conditional statement and its converse, and is usually written in if and only if form. So in this example, I'm not happy if and only if it's raining is the same thing as saying, if I'm not happy, then it's raining, and also, if it's raining, I'm not happy. It's just combining that statement and its converse into one biconditional statement. Right here, let's practice writing the converse to the following statement. And then we'll look at if the converse is true. If it's true, we'll write a biconditional statement, and if not, we'll find a counterexample. So, the converse to this statement right here, if a shape is a square, then it's a quadrilateral, would be if a shape, so we'll say if a shape is a quadrilateral, so we'll write if quad, then a shape is a square. So then square. That would be an abbreviated version of the converse. But this is not true because I could think of a counterexample which would be a quadrilateral that's not a square. So one thing would be maybe a rectangle, and another counterexample would be a rhombus. So, the converse to this statement is not true. Let's try another example of writing the converse and then seeing if the converse is true. So, this conditional statement right here reads, if you divide a number by 2, then the result is an integer. Then that number is even. The converse would be, if a number is even, then when you divide a number by 2, the result is an integer. I can't think of any numbers that are even but are not divisible by 2. Therefore, this statement is probably true. So, a biconditional statement would be a number is even if and only if when you divide a number by 2, the result is an integer. Alright, if we have a homework check in class, do you watch this video? Remember that the homework password is Derek Jeter. Write that down. Alright, the last type of conditional statement we'll learn about is an inverse statement. The inverse statement negates both the hypothesis and the conclusion. So negate just means make opposite. So if the original statement is, if it's raining outside, then I'm not happy, then the inverse would be, if it's not raining outside, then I am happy. So like the opposite of raining is not raining, and the opposite of not happy is happy. But remember, we do not switch the position of the hypothesis or conclusion. Alright, so let's practice writing the inverse to this particular conditional statement. If the Giants win, Mr. Scavola will be happy. Try to think of the inverse and pause the video while you're doing it, and then hit play when you want to see the answer. So, the inverse of this statement would be if the Giants lose, or you could have said if the Giants do not win, Mr. Scavola will be sad or unhappy. So again, we keep the hypothesis and conclusion where they are when writing the inverse, but we negate both the hypothesis and the conclusion. Alright, that's the end of the video. Thank you for watching and have a good one.